question. So summary we done. So let me skip that part. Question. Yeah. Supposing that there are two people and suggest the following way to make sure that the two people have the same key. Just want to verify that the key with me and key with Yamini happen to be the same. So mechanism is, what I'll do is I create a random bit string, XOR it with the key and transmit the encrypted XOR value. So assuming I have a key and I want to make sure that me and Yamini has the same key. So somebody said, just to verify, you can do the following. I'll take a random number, encrypt using my key, and then transmit to Yamini. What Yamini does, she takes the received value, encrypt the received value with the key. So assuming my key was K, I take a random number, XOR with my random number R, I get a value X, and I transmit the value X to Yamini. Now Yamini, what a Yamini does, Yamini take this X, XOR with the key again, and this will give a random number. This is the property of random number. So when I get the random number back, I know what I'm getting is what I started with. If the two are same, then we have a same key. If she gives me something else, we don't have a same key. Because if she is using a key K dash, my value would be different. So this mechanism, we can certainly verify that me and Yamini share the same key. Is there a flaw? Assuming Manjunath is watching all this phenomena, can Manjunath figure out what are our keys? Think for a minute, discuss, and let me know, is it possible for Manjunath or somebody else to figure out what our keys are? We have not communicated the keys. Just think about it. 2 minutes, think, and then give me the answer. I literally give you the answer. Discuss, that's fine. Feel free to discuss, let me know. We have verified that we have the same key, but for a listener, passive attacker, can he figure out what our keys are? Did you get the question? Samita, you got the question. So can you, when I'm communicating with Yamini this, can you figure out our keys? No? What about you? Can you figure out the keys? Yeah, passive attacker knows X, passive attacker knows R. Yeah, so if we look now, I had the key K, I took a random number R, I did XOR operation, I got the value X. And X is communicated to the Yamini. Yamini take the value X, XOR with the key, get the random number R back, communicates me, and I can confirm with that receive value same as this. So we confirm that we have the same key. Now attacker or passive attacker has seen the value X, also seen the value R. So if you do XOR of X and R, what will you get? So you got the keys. So this is a way of verifying you have the same key, but this mechanism exposes that everybody can know what our keys are. So certainly not a good method. Are you clear about it? You can look at the example, that's fine. Any question about this? Clear, Rafa? Doesn't really matter. I'm saying somebody suggested a way. So that means way is not good enough. It's a very bad method of verifying. That's all we are saying. Let's look at the second question. Consider a symmetric block encryption algorithm in which we are using, let's say, 64-bit blocks of plain text using so we have a 128-bit key. We divide it into two parts. One part is K0 of 64 bits, and one part is another 64 bit is K1. And what we are doing is we take the text, which is the plain text P, XOR with the K0, and remaining portion we do what is called addition mod, because 64 bit, so we do a mod 64, mod 2 raised to 64 addition. So we take first key K0, XOR with the P, then we do the add operation with modulo 2 raised to power 64 with second part of the key, and generate the ciphertext. This ciphertext. How would you decipher this? Assuming receiver has the keys. What is the operation receiver will do to get the text P back? 2 minutes, work it out. If anybody doesn't understand the question, let me know. I'll explain the question. Rupa, is the question clear? So assuming I have given this text, you have the keys, both K0 and K1. What you will do to the ciphertext C so that you can get back the text. If you have a doubt, ask me. If somebody is done, let me know. I want to look at what you have done. Yes, Arafat. Write the expression. If you do XOR with K0 and do this, you will not get P. No, this is not the right answer. That's the reason I'm asking this question. So to get the value, you do reverse operation. So reverse operation is, first you need to obtain this part. Given K1, how do you operate? How do you get this part? How do you nullify the effect of K1? Let's say you have some number X. Let's say you had some number 54 or something. You added 28 to it. It gave you 72. Right? How do you get 54 back from 72? So in the decimal point, so can you add something to 72 to get 54 back? Because I'm doing, see, I have operation only additive operation. And we are doing the modulo word. That means anything goes beyond 100 will fall back. So what you can add to 72 so that you'll get 54 back. What is additive inverse of 28? Additive inverse of 28. Additive inverse. so that when you add to it, you get 0. So how do you represent in the plus numbers? It will be basically your 72 or something. When you add, you'll basically get the same numbers. So 54, so it gives you, 54 plus 28 gives you 82, not 72, right? Now additive inverse of 28 is 72 because 28 plus 72 is 100, and if I take the modulo of, I get 0. So if I take 82, add 72 to it, what do I get? I get 154. I'll take modulo 100, I get 54 back. So what I'll do is, I'll find additive inverse of K1, which is my key. So I had the key K1. Let's say minus K1 happens to be my additive inverse. Like I said, in the base 100, additive inverse of 28 is 72. I'll just give you the example there. So assuming there's minus K1 some number, which is the additive inverse of K1, so you do the plus operation with the ciphertext. This will give you P plus K0, P XOR with K0. And I again XOR with K0, I get the text back. So don't try to first use K0. You have to use additive inverse of K1, so that you will get P XOR with, this gives you P XOR with K0. So this gives you P XOR with K0, and when you XOR with K0 again, you get the P back. Any doubts? Clear? Let's move on to next question. Consider the security services. We looked at digital signatures. We looked at message authentication code. What is message authentication code? We discussed last lecture. Yeah. Using some key. Okay. So using some key, there is a message authentication code. So assuming we are using either digital signatures, we know what digital signatures are, or we are using message authentication codes, and we assume that somebody is able to observe all the messages. Oscar, somebody is able to observe all the messages, and Oscar has no knowledge of any keys. Oscar is a passive attacker. He has no knowledge what the keys are. Now what you're trying to say is, we want to look at few conditions and say, are those conditions, by using DS and MAC, can they be secured? Can Oscar figure out what is going wrong? So question is, let's say Alice sends a message to Bob, transfer $1,000 to Mark in clear text, and also send authx to the Bob. Authx means using DS, digital signature, as well as using your MAC part of it. Oscar intercepts the message and replaces, so my message in clear text, he says instead of Mark, it makes it to Oscar. Now, can Bob figure out that message has been corrupted? If I am using digital signature, or if I am using message authentication code, and Oscar has modified the message, can Bob figure out either the mechanism that message has been tampered with? So with digital signature, can yes. With message authentication, is it possible? Give a thought for 1 minute again. That will make you clear the difference between DS and the MAC, message authentication code. Using DS, using MAC, can Bob figure out message is tampered? Or it can found only with one, not with the other. Okay, what about Mac? No? Prakash? whatever, so that is whatever, we are just doing only this much. Don't bring in extra information there. Both. Because what is my, I'm doing a hash, signing it, keys are known to me, so my hash would change. If I'm doing message authentication code, the moment message is changed, my hash value would change. So when I generate my own hash, it will not match. So it doesn't really matter whether authx was DS or authx was MAC. In both the cases, you will be able to figure out that message is corrupted. Is that okay? Mr. Sweeney? Fine. Let's look at second question. Assuming Alice sends a message, transfer $1,000 to Oscar. And this is a message given to Bob. Now what Oscar does, and repeat this message 100 times to Bob. Assuming my network is not losing any messages, can Bob detect that it is the same message duplicated 100 times, or will Bob end up paying $1,000 100 times? Do you get the question? If I'm using authx as digital signature, or if I'm using authx as MAC, can Bob figure out that somebody has replayed this message 100 times, so I don't have to pay 100 times. It's the same check, no, there's not many 100 copies of it. Is it possible for Bob to figure out if mechanism was using digital signature or mechanism was using MAC? No, message is the same. Message is this. It will have same. If same text, it will have same value. Given input text can't have a different hash value. But this is what we send. So all we are sending is message and your authentication information, which is either the digital signature or the MAC code. So message communicated is either the message communicated is the text part of it, plus either the digital signature or the MAC. That's all you're communicating. Now, is it possible for Bob to figure out that it is the same message repeated 100 times? Kalyani? Yes, no? If I were to do this, will you do that? Can you detect this is a fraud? Can you find out? Yamini? You don't know the answer, or you are saying no, you cannot find out? Cannot find out. Yes. So next question, I given the answer. So is sender Oscar claims that he sent some message to X with valid value to Bob, but all Alice claims the same. Oscar sent, I sent a message to Bob, but Alice says, I sent the same. Can Bob be clear whether message was from Alice or message is from Oscar? Is it possible? So essentially, if it is a digital signature, my public key is known, then you can basically verify for Alice, or similarly, if secret key is known, then I could. So Bob would be able to verify, because if Alice is signing with a private key, if Oscar is sending it, Oscar would be signing with his key. Oscar doesn't have a private key of Alice, Bob. So Alice can, or Bob can figure out who's sending it. So both the mechanisms we should be able to figure out. Next is again, Bob claims that he received a message X, but Alice claims he never sent it. Then using either DS or MAC, can you figure out? So in that case, I need to basically ask for that now there is a difference there. In this case, Alice is asking Bob to send the copy of the message with signature. A message is generated by the Bob's public key because Bob generated the message, I would know. If it's a plain authentication code, You probably have a key there. Let's see what is happening there. So message is sending. Bob claims he received a message X, and Alice says he never sent it. If I receive a message with signature, will be if I'm using some kind of only a plain authentication code with some keys which is common, then probably I would. So if the key is known, then the key is known to come, then Alice cannot deny that she is not sending a message because key is known to everybody. But private key is known only to Alice. So Alice could say, if you give me the message, I could not send it. Okay. So go through this, and next questions will probably discuss our encryption algorithm, what DES is, how does triple dash works, how does RSA works, and if you have access keywords. That will stop.